Hey team, today we're going to be setting our sights on issues related to construct validation. Many of you are doing comps projects on issues related to validation of experimental manipulations or psychological measurements. So today we're going to talk about what you should be looking for in the papers you're reading to help you evaluate whether and how these manipulations have been validated. So we'll talk both about measured variables and manipulated ones. So measured variables are those that researchers want to evaluate that are pre-existing within a participant. Whereas manipulated variables are those that the researcher is trying to influence or control. So if, for instance, I'm doing a study about mood and I want to measure somebody's mood, I could give them a questionnaire, I could have a professional interact with them and provide some kind of rating, or I could maybe use some kind of behavioral observations in order to measure that underlying construct of mood. If I wanted to manipulate mood instead, I could try to induce those feelings in different ways by asking participants to think about a time they felt sad or maybe watch sad videos. So the Flake et al. Article that you read for today dealt with issues related to measurement, and the Chesker and Lasko article dealt with manipulation. We'll talk about them both. And the question that we are going to try and tackle is, how do we know whether the variables that we are measuring are actually measuring what we think they are? How do we know whether our manipulations are working? We talked in the unit on measurement about jingle and jangle, about the fact that there are typically many different instruments to measure the same construct. So how do we know which one we should use? That's what we're going to explore. Let's start our discussion about construct validation of measured variables with a little field trip. We're going to the laboratory of noted psychometrician Dr. Jang Gall. Hello, welcome to my laboratory. Are you ready to be part of some groundbreaking research?
Yeah, sure.
Great, come right over. If I can ask you to please lay your arm along the measuring instrument. Okay. The readings I'm getting indicate that your level of enthusiasm is moderate.
Wait a minute. You think that thing's measuring my enthusiasm?
Well, yes, this is an enthusiasmometer, as you can clearly see. So it must be measuring enthusiasm. Thanks for coming in.
Hey, Julia.
Yeah?
It was really cool to be in that study, but frankly, I have some concerns.
Like what?
Well, first of all, I'm sure that rolling a dice is going to make me have a different score every time. And also, it doesn't seem like the measurement of enthusiasm that she got there is going to be at all related to like...
Hold on. Why don't you tell me your concerns just one at a time, and I'll see if I can help you address them.
Okay, first of all, she rolled a random number and made that part of my score. So that definitely means my score is going to change every time.
Sounds like you have some concerns about reliability, or the extent to which the data are consistent. In particular, you're concerned about a thing called test-retest reliability. So that's the extent to which an instrument gives stable results over time. So one way that we can assess this is to get scores from lots of participants on multiple occasions and assess the extent to which they're related. So you take a test one day, then you come back in 6 months and you take the exact same test. How much do your scores change? So in the example that I'm showing on the screen here, the scores aren't changing very much. So we'd say that those scores are pretty reliable from time 1 to time 2. So we'll commonly see information about test-retest reliability reported in papers as a correlation coefficient. So here the correlation of 0.87 indicates that people's score on this measure at one time was highly correlated with their score at another time. You'll also see reliability evidence evaluated for multiple forms of the same scale. So you may see like a long version of a survey and a short form that's intended to be easier and faster to administer. If patients take both tests on the same day, the correlations between those tests gives an indication of how well the short form is consistent with the long form. Another type of reliability that you might be interested to know about is inter-rater reliability. So this assesses the extent to which some subjective quality is judged similarly by multiple judges or observers. So if you have two clinicians who are both making judgments about some participant's behavior, you'd want to measure whether those two judges are being pretty consistent in the way that they're evaluating the participant. Finally, you're likely to encounter evidence about internal consistency. So this is assessing how consistent the results are for different items within the same measure. So for example, let's imagine we have a 6-item questionnaire. we could calculate the inter-item correlations among those 6 items to assess whether the way that people respond to one question tends to be correlated with the way that they respond to other questions. If all 6 of those questions are measuring the same thing, participants should be responding to those in pretty similar ways. You may also see split half correlations to measure internal consistency, where you randomly select items from a survey and see how closely related 2 halves are with one another. So we randomly select 3 items and randomly select 3 different items, and then see how much those 2 halves of the survey predict one another. Among the most common metrics you'll see for surveys and questionnaires is Cronbach's alpha. Although this isn't exactly how it's calculated, the value represents the average of all possible split half correlations. So if you were to take the split half correlation that I described just a moment ago, and then randomly split the items in the survey in another way and correlate those 2 halves, and so on, until you have calculated the average correlation of every possible combination of split halves, that is computationally equivalent to the Cronbach's alpha. So it gives an indication of the extent to which items in the measure, items on the survey, for example, tend to hang together, how consistent the results are for different items. So I see why you'd have some concerns about reliability, because given that there's a random number in there, yeah, the enthusiasmometer is probably not likely to be super reliable from time to time. What else are you worried about?
Well, yeah, also, it doesn't make any sense why a tape measure should be related to enthusiasm.
So now you're talking about validity, the extent to which an instrument or test measures what it's supposed to measure. In fact, it sounds like you're particularly concerned about face validity, which is the extent to which it seems reasonable that the test measures the intended construct. We don't have any theoretical reason to expect that arm length should predict enthusiasm, so it's pretty weak face validity for the intended construct. It's important to keep in mind, though, that face validity is a pretty weak kind of validity because it is inherently so subjective. So it's a reasonable first pass. It's a reasonable first question you might ask of, does it seem reasonable that this test could be measuring this construct? But it's not enough. We certainly need more. So let me guess, there's something else that's wrong?
Yeah, there's another thing. It kind of seems like the measurement she gets from that tape measure is going to be more closely related to like my arm length or my height than my level of enthusiasm.
Okay. Yeah. So I think you might be onto something there. So this concern is about another form of validity called discriminant validity. So discriminant validity assesses the extent to which things that are supposed to be distinct and separable from one another are in fact distinct. So for example, 2 latent constructs, the underlying constructs that we're actually interested in, but we can't directly measure, of height and enthusiasm are not supposed to be related to one another. There are no models in psychology where more enthusiastic people are taller or something like that. And we have a way of measuring arm length. I just use a ruler, measure your arm, and that is supposed to predict height. And we have our enthusiasmometer, which is supposed to measure enthusiasm. So if we measure arm length and we get your enthusiasmometer score, they should be unrelated because the underlying constructs they represent are unrelated. But, they are in fact highly related. This is a problem because it indicates poor discriminant validity. These things are supposed to be unrelated and they're not. So yeah, we might have some issues here. Anything else you're worried about?
Well, yeah, I feel like that number she got isn't going to be at all related to, like, self-report measures of enthusiasm.
Yeah, good questions. Aren't these good questions? Okay, so you're also concerned about convergent validity as well. So convergent validity assesses the extent to which measures that are supposed to be related to one another are in fact related to one another. So if you want to measure enthusiasm, rather than using the enthusiasmometer, we could get individuals' ratings of their own level of enthusiasm, right? Get self-report ratings, how enthusiastic are you on a scale from 1 to 7, have a survey or something like that. So that is also supposed to tap into the underlying construct of enthusiasm as well. So if we compare levels of enthusiasm from the enthusiasmometer and the self-report measures, they're not related. They should be. They're both supposed to measure the same underlying construct. They should correlate with one another. If they aren't, that indicates weak convergent validity. I want to mention at this point that discriminant and convergent validity are both subtypes of what's called construct validity. So when you hear and read about construct validity of various measures, it's typically referring to both discriminant and convergent validity. Okay, so how are we doing? I mean, the enthusiasmometer is not holding up very well. Is there anything else you're still worried about?
I feel like the numbers that she got from that aren't going to predict any kind of real world behavior. Like, I don't know, how many exclamation points I use in my emails or something like that.
Yeah. So she's also concerned about predictive validity. That is the extent to which a measure predicts outcomes that are related to the intended construct. So if I know something about your score on this test, if I know something about your enthusiasmometer measure, I should be able to predict something about your real world behavior, right? People who have higher scores on the enthusiasmometer tend to also ... So maybe that's more exclamation points in emails, maybe that's talking more loudly, but there should be some kind of real world application for knowing that about someone. And for the enthusiasmometer, it isn't anything that has to do with enthusiasm. So, in conclusion, I think we can determine that the validity evidence for this particular instrument is rather weak. Back to the drawing board, Dr. Gall. In addition to measuring variables, researchers may also want to manipulate variables. So rather than taking some variable that already exists within people, they may want to deliberately induce those states. So here's an example. Dr. Jan Gall is at it again. This time she's interested in how mood affects cognition. Specifically, she thinks that sadness will impair attention. So she creates a study in which she randomly assigns participants to be in either a sadness induction condition, so they do something to the participants to try to make them sad, or a control group that doesn't induce an emotion, or rather induces a neutral emotion. Then both groups take the same attention test. Dr. Gall makes sure that she has highly powered analyses. She pre-registers her study, and after the fact, she plans to share her data and materials. She runs the analyses and, great news, finds a p-value that is very small for the main analysis. It is statistically significant. It gets sent off to the big journal in the field, and Dr. Gall is very happy. So, what could possibly be the problem? Well, let's look back at how Dr. Gall induced sadness. In this study, they decided to induce sadness by presenting the participants with sad movie clips. And the participants would watch those sad movie clips for an hour. Participants in the control condition watched neutral clips. So here's some footage of the sad movie clips. And here's some footage of participants watching the sad movie clips. So what this study neglected to do was to ensure that the thing they were trying to manipulate, sadness, was in fact being induced from the sad movie clips. Maybe the participants were just really bored. Maybe boredom harms attention. Maybe it isn't about sadness at all. So that's still an interesting finding. Boredom impairs attention, but it's a different finding. And unless we know exactly what state we have manipulated or induced within those participants, we don't know the reason that attention has been impaired, right? We don't know the mechanism. So without additional validation of our manipulation, all we know is that something we did harmed attention. So how do we know whether it was actually sadness? Well, one thing we can do is run a pilot study to ensure that our manipulation actually affects what it was supposed to affect. So before we run our main study, we just run participants through the same kind of manipulation, but then rather than measuring attention, we give them questionnaires, physiological measures, any other way of assessing whether sadness has actually been induced. So that way we know that when people watch those sad movies, they actually feel sad, but they don't in fact feel more bored. Then when we run the main study and see that the sadness manipulation affects attention, we can be more confident that it's actually because they were sad. We'll talk in class about manipulation checks that are done within the same study and what the benefits are to doing pilot validity testing versus using manipulation checks within a study. So as you're reading papers for your comps, I would encourage you to keep these questions in mind. Where did the measures or manipulations come from? Did the researchers just make them up on the fly? If they are pre-existing measures from another study, were they modified in the current study? And how have they been validated? Keep in mind that face validity is not enough. Watching sad movies doesn't guarantee people are going to be made sad. Just because a test is called a measure of X doesn't mean it actually measures X. And finally, read with a really critical eye. I think it's easy to look at studies and say, well, we have a questionnaire for sadness, therefore we know it measures sadness. But you shouldn't assume that measures are reliable and valid just because they are in the published literature. And don't assume that two measures that have the same name necessarily measure the same thing. In class, we'll talk through additional examples of construct validation and talk more about how you could apply these concepts to your comps papers. Thanks for tuning in. See you next time.